NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
It's not easy to put men on the moon. One of the problems is to know just where to land once you get there. A series of picture-taking lunar orbiter spacecraft are helping to solve this problem. The most recent flight, Lunar Orbiter 3, recorded and transmitted pictures of 12 potential landing areas. Much new scientific knowledge has been returned in addition to the lunar landing information as a result of the orbiter series of pictures. We now know more about the moon's shape and its gravitational field. Meteoroid measurements will help designers of future spacecraft determine if the small, high-speed particles are a hazard. Actual amounts of radiation can also be measured. This series of pictures shows not only a potential landing area for astronauts, but the place where Surveyor 1 landed. The mountain range shown here in a lunar orbiter photograph looked like this to Surveyor on the moon's surface. These are some of the other primary site photos, and one of the hidden side of the moon. Lunar Orbiter, recording views of the moon in greater detail than is possible through Earth-bound telescopes, detail needed to help select sites for safe lunar landings. This unusually dressed man has an interesting specialty. He makes small models used in wind tunnel research, models of supersonic airplanes and spacecraft, many for missions yet unflown. The specialty, called lost wax casting, dates back to the ancient Egyptians. In the days of the pharaohs, artifacts and religious symbols were made using a similar technique. The work is done at NASA's Ames Research Center in California. The process goes like this. Wax is injected into a die. The solid wax model is then removed from its mold. An improvement on the process up to this point is used to make extremely thin castings, as thin as 10,000ths of an inch. Instead of wax, sheet plastic is vacuum formed to the desired shape, like the lifting body spacecraft shown here. Following this, the model, in this case wax, is dipped into a wetting solution and then swirled about in a sand-like mixture which adds a thin outer shell. Additional coatings can be added to make it thicker. When completely dry, the model is placed in a burnout furnace where the wax is melted away. In addition to melting the wax, this cures and leaves a clean ceramic shell. Next, molten beryllium copper is poured into the newly formed shell. For very thin-walled models, the mold is placed into a centrifuge while still at the melting point. This G-loading forces the metal into all the intricate details of the mold. When cooled, the shell is broken away, exposing the casting. After being sandblasted, the model is given a final polish. Its last stop will be the wind tunnel. Tiny thermocouples placed inside the thin model will return accurate heat measurements. Information needed before spacecraft re-enter the Earth's atmosphere or passengers travel supersonically. Model builders making improvements on an old technique and contributing to future air and spacecraft development.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.